Greetings, universe investigators. Welcome to Investigating the Universe, your cosmic hub for making sense of complex scientific concepts. We're here to take you on a journey, transforming the abstract into the comprehensible, the intricate into the graspable. Today we're embarking on a thrilling exploration into an intriguing question. Does antimatter create anti-gravity? It's a question that's puzzled scientists for years, and we're about to delve into it. Now, strap in, as we dive deep into the realms of antimatter and anti-gravity. Imagine a mirror universe to ours, where everything is the exact opposite. That's what antimatter is to matter. In this intriguing world of physics, antimatter is a concept that truly boggles the mind. Simply put, it's the evil twin of matter. But what does that mean exactly? Well, every particle in our universe has an antiparticle, its mirror image. These antiparticles are eerily similar to their counterparts, except for one key difference: their charge. If a particle is positively charged, its antiparticle is negatively charged, and vice versa. This mirroring extends to other properties as well, including spin and magnetic moment. Now let's talk about how this elusive antimatter comes into existence. The creation of antimatter is a cosmic spectacle, happening in high-energy processes like cosmic ray collisions or in particle accelerators here on Earth. When energy is converted into mass, as per Einstein's famous equation EMC2, both a particle and its antiparticle are created simultaneously. But here's where things get interesting. When matter and antimatter meet, they annihilate each other, disappearing in a flash of energy. This phenomenon, known as annihilation, is a testament to the volatile relationship between matter and antimatter. It's like a cosmic dance, where partners annihilate each other instead of bowing out gracefully. So, why don't we see antimatter in our daily lives? The simple answer is that our universe, for reasons still unknown to us, is overwhelmingly dominated by matter. Antimatter, it seems, has been largely banished to the fringes of the cosmos and the confines of our laboratories. But in this vast universe, nothing is ever truly off-limits. Scientists are still exploring the mysteries of antimatter, and every discovery brings us one step closer to understanding the fundamental nature of our universe. So, if antimatter is the mirror image of matter, does it fall up instead of down? Let's explore. Anti-gravity. It sounds like something out of a science fiction novel, doesn't it? But what if I told you it's a concept that has been contemplated and studied by scientists for years? Let's delve into this fascinating topic. Imagine a force that repels rather than attracts. A force that could make objects float and fly, defying the very nature of gravity as we know it. This is the concept of anti-gravity. It's a notion that flips our understanding of physics on its head, proposing the existence of a force that is the exact opposite of gravity. The idea of anti-gravity is still largely theoretical. While it's a popular topic in science fiction, its existence in our real universe is yet unproven. However, that hasn't stopped scientists from exploring this concept. Theoretical physicists have proposed several ways in which anti-gravity could exist, and these theories are still being tested and refined. The implications of anti-gravity, if proven to be true, are staggering. It would redefine our understanding of the universe, of matter and energy, and even of space and time. It could revolutionize transportation, making space travel easier and more accessible. It might even make hoverboards and flying cars, staples of science fiction, a reality. But as exciting as these prospects are, it's important to remember that they are still just possibilities. Until we have solid evidence, anti-gravity remains a theoretical concept. It's a tantalizing puzzle for physicists, a mystery that's yet to be solved. The concept of anti-gravity also raises some intriguing questions. For instance, if there's matter and antimatter, could there also be gravity and anti-gravity? Could antimatter perhaps generate anti-gravity? These are the questions that scientists are currently grappling with. Now, let's connect the dots between antimatter and anti-gravity. Antimatter and anti-gravity, two intriguing concepts. But do they relate? Let's dive into the fascinating world of theoretical physics to explore this question. First off, what is antimatter? Antimatter is the mirror image of matter. For every particle that makes up the world we know, there's an antiparticle with the same mass but opposite charge. When matter and antimatter meet, they annihilate each other in a burst of energy. A concept that's fundamental to the plot of many a science fiction saga. Now, let's talk about anti-gravity. In the simplest terms, anti-gravity would be a force that repels instead of attracts. It's the stuff of science fiction fantasy. Imagine floating cars and gravity-defying gadgets. But could it be more than just a dream? This is where the connection between antimatter and anti-gravity comes into play. Some theories suggest that antimatter might not fall down, it might fall up. In other words, antimatter might exhibit anti-gravity behavior. The idea is compelling, but how do we test it? One way is through the ALPHA experiment at CERN. Researchers here are studying antihydrogen, the antimatter counterpart of the simplest atom, hydrogen. They're trying to figure out whether antihydrogen falls up or down under gravity. The experiment is incredibly delicate. Antihydrogen is produced in a magnetic trap where it's held away from the walls of the experiment, which are made of matter. If an antihydrogen atom touches the wall, it will annihilate, so it must be kept suspended in midair. Once the antihydrogen is produced, the magnetic trap is switched off, and the atom is allowed to fall freely. By observing where it annihilates, researchers can determine whether it fell up or down. This experiment is still ongoing, and results are yet to be definitive. But the implications of antimatter exhibiting anti-gravity behavior are enormous. It could revolutionize our understanding of the universe, opening up new possibilities in space travel, energy production, and much more. But for now, it remains a tantalizing possibility. The world of antimatter is still shrouded in mystery, and there's much we have yet to learn. As we continue to push the boundaries of our knowledge, who knows what we might discover? While the connection between antimatter and anti-gravity is still being explored, the implications of such a discovery would be revolutionary. So let's keep questioning, keep investigating, and keep dreaming of what might be possible in this vast, mysterious universe. We've journeyed through the world of antimatter and anti-gravity today. It's been a fascinating exploration, so let's bring it all together. We started our journey by shedding light on what antimatter is. Remember, it's not some science fiction concept, but a real component of our universe. Each particle of ordinary matter has a corresponding antiparticle, identical in every way but with an opposite charge. When matter and antimatter meet, they annihilate each other in a burst of energy, a fact that has intrigued and puzzled scientists for decades. We then delved into the concept of anti-gravity. It's a term that stirs the imagination, evoking images of floating objects and defiance of the laws we know. Anti-gravity, as we discussed, is the idea of counteracting the force of gravity. While it might seem like this stuff of science fiction, it's an active area of research in theoretical physics. The heart of our discussion was the intriguing question, does antimatter create anti-gravity? This is a question that has been at the forefront of scientific research. Theoretical physicists have postulated that antimatter might fall upwards, essentially exhibiting anti-gravitational behavior. However, this is a topic of debate and ongoing investigation. The truth is, we don't have a definitive answer yet, but scientists are using cutting-edge technology and conducting experiments to figure it out. The potential implications are enormous, from revolutionizing our understanding of the universe to potentially paving the way for advanced propulsion systems. But it's important to remember that these are possibilities based on a question we're still trying to answer. In conclusion, the relationship between antimatter and anti-gravity is a tantalizing mystery at the frontier of modern physics. It's a testament to the fact that our universe is full of wonders and enigmas that we're only beginning to understand. And that's what makes the journey so exciting. Remember, the universe is full of mysteries waiting for us to discover. Keep investigating, and we'll see you in the next video. Don't forget to subscribe to Investigating the Universe and share this video. Your likes are the fuel for our exploration. Until next time, keep looking up.